All right, in lesson 2.3, we're going to talk about rate of change. We have rate of change here. We're talking about rate of change, which is very similar to slope. It's like synonymous with slope. Rate of change. Rate of change is a ratio, and it compares how much one quantity changes on average relative to the change in another quantity. Okay, now the key here is the x value. The x is the independent value, whereas the y is the dependent. We learned that before. We talked about domains and ranges, inputs and outputs, x's and y's. Well, x's are the independent, and the y values are the dependent. So we have the rate of change equation. It equals the change in y over the change in x, which you also will see sometimes referred to as this symbol here. This is like, it looks like a triangle Y, but it's a delta. It's a delta. I think it's a Greek letter delta Y, which means a change in Y over the change in X. So again, very similar to slope, because slope is the rise over the run. So you find the change in the rise, and you find the change in the run, and you get your slope. That's where the slope comes from, rate of change. Okay, let's move this, grab my screen here. A couple of real world examples that we can take a look at. Chemistry. The table shows, let's see if I can get this working, the temperature of a solution after it has been removed from a heat source. A lot of times there's a burner or a heat source. Find the rate of change in temperature for the solution. So over in this side here, you have a T-chart shown. It has the minutes and it has the temperature. So the time is like the input value. That is independent. And the temperature depends on how long of time it's been heated, or it's removed from the heat source, so it's actually cooling. And you can see what's happening to the temperatures, right? They're falling. So it says, find the rate of change. So that's what we're going to do. We're going to find the rate of change. To do that, the rate of change is change in y over change in x. So you need to grab two ordered pairs. So we grabbed this one here, which 2 minutes, the temperature is 139.4 degrees Celsius, and in 5 minutes, it was 133.1, so temperature is dropping. So you find the change in the y's, you subtract the temperatures, and you subtract the x's, the change in the x values. And notice, it's a negative change. The rate of change is negative 2.1. What does that mean? A negative change would be a decrease in 2.1 degrees Celsius every minute per minute. 2.1 degrees Celsius every minute, it drops. Okay? Let's look at the next sample. Recreation. This one's about recreation. The graph at the right shows the number of gallons of water in a swimming pool as it's being filled. If you have a swimming pool, you probably empty it every once in a while, and you got to get it filled. Big tank truck comes. Question is, at what rate is the pool being filled? So we're looking for the rate of change. All right, so what I would do is to find the rate of change of the pool being filled, I'm going to have the rate of change, ROC, I'll call it. You find that by the change in the y's over the change in the x's. Now the y's are the dependent. The y's on the y-axis it's the water, the gallons of water. So the y's are the gallons of water. Okay, and how many gallons of water, right, depends on the time you fill the pool. The longer you fill up the pool, the more water is going to be in it. So then you're going to grab ordered pairs. So there's two ordered pairs that are already given to us. You have to find the ordered pairs. You look at the x coordinate, the y coordinate, and the x coordinate, the y coordinate. You have these ordered pairs. So you grab the y's and you subtract them. Let's use the 252 first, minus the 108. Then you go back to the 252. The x-coordinate is a 7, so you start with that, minus the 3. And you end up with 36 gallons per minute. So you did your subtractions in the numerator, subtraction in the denominator. Now you might say, what if you had done the 108 minus the 252 and then the 3 minus 7? You would have had a negative over a negative, which still would have been a positive, and it still would have been a positive 36. So either way, it would have worked out. All right, if you go to the back of that page, it talks about up to this point, you've used rates of change that are constant. Many real-world situations involve rates of change that are not constant. Well, if it's constant, a constant rate of change is going to give you a straight line. It's linear. All right, that would be linear. But sometimes, as you can see in graphs, the rates are not linear. They're up and down. Sometimes they're smooth curves like we talked about. And in that situation, you talk about the average rate of change because of the ups and downs. You just kind of pick one point, pick another, and do the average rate of change over time. All right, so that leads us into final part of this lesson, slope. We're talking about slope, and quick review of slope. Grab my highlighter. Slope of a line is the ratio, so it's a comparison of two numbers of the change in the y-coordinates and the change in the x-coordinates. So slope, just like rate of change, is a change in y's of the change in x's. We call y2 minus y1 over x2 minus x1. So you get the coordinates, the ordered pairs. So you can start with y2, subtract y1, and x2 minus x1. So hopefully you remember that from Algebra 1. We have a key concept box here, which reminds us about slope. Key concept box here. Slope of a line is a ratio. And we use M to represent slope. I don't know the history of that, but M is slope. And here is the slope formula using two ordered pairs that are on the line. Okay? And down below, there are a couple examples reviewing how to, if you have ordered pair, you just take the change in y's over the change in x's, and you simplify, and your slope would be, in this case, 1/3. So make sure you simplify the final answer. That's always key. So you should be able to take two ordered pairs and find the slope. Now, the other thing you should be able to do is, if you're given a line, move this up. If you're given a line on a graph, like right over here, there's a line right here. Whoops, come on, stay there. There's a line right here. It's moving on me. So you should be able to pick out two ordered pairs from that line. And we know from our other study, the best two ordered pairs to use are the intercepts, if you can read the intercepts. Okay, so you take those and you use those for the y's, the 0 and the -3, and then the -2 and the 0 for the x's, and get your slope that way. All you got to do is pick 2 points off the line. Doesn't have to be the x and y intercepts, though. It could be any two ordered pairs on that line, just like it showed you here on this first example. Any two ordered pairs you pick off, you should be able to find the slope.